Hello everyone. This is homework number 2, an introduction to percents. And we start with the basic definition or concept of a percent. And it means per 100. And always remember per means division. So basically means divide by 100. And I'm sure we're all familiar with the percent symbol. That's the way I make it. So get used to it looking like that. And just based off that concept, we can answer a few questions. And then we're going to develop some shortcut methods. But if we want to write 92% as a fraction in lowest terms, since the percent symbol means per 100 or divide by 100, we could say that 92% is equal to dropping the percent symbol 92 divided by 100. And then we could reduce the fraction. So to reduce the fraction, we want to pick a common factor. Doesn't have to be the greatest common factor. For example, I'll notice that both of these numbers are even. So therefore, I'm going to divide by 2. So that gives 46 over 50. But I see that both of those numbers are even as well. So I could reduce further by, again, dividing both by 2. And that gives me 23 over 25, which is the fraction in reduced form. There is no common factor. Or if you did pick the greatest common factor, and you started with the 92 over 100, turns out that 4 was the greatest common factor. 2 times 2, because we did 2 twice. And then that would immediately get you to 23 over 25. But it's not necessary to pick the greatest common factor when reducing. All you have to do is pick a common factor. And then if you have to do it more than once, like we did here, then so be it. Now, one other thing on your calculator, if you purchased the TI-30X2S or you have a similar type of calculator, on this calculator right above the SIN or sign button is A with a B over C. That's our fraction key. So this is a very useful key. If I turn on the calculator, and I'll just clear it, I could reduce this fraction, 92 over 100, by first typing in 92, then hitting that fraction key. And notice on the display how the calculator has the little upside down backwards L there. That's its way of indicating a fraction bar. And then I type in the denominator of 100 and press equals, and it reduces the fraction immediately for us. So very helpful to have a basic scientific calculator with the fraction key. Okay, so again, still working off this basic definition. Percent means per 100 or divide by 100. We now want to write 7% as a decimal. So 7% I could first express as 7, drop the percent symbol over 100. And then to change it to a decimal, we'd have to do division. So I know nobody's going to go through the process of long division, but 100 goes into 7. No, it doesn't. So we add a 0 and a decimal point. 100 doesn't go into 70, so add another 0. 100 goes into 700, 7 times. Bring up the decimal, placeholder of 0, and 7 times 100, 700. Subtracting, we get a remainder of 0. So this is 0.07, or I always like to put a 0 out in front of the decimal point if there is no whole number portion. And then the decimal portion is highlighted even better by the 0 out in front of the decimal. So 0.07 is fine. I like 0.07. And what we can notice about what just happened, and of course if you do this on the calculator, all you're doing is division. So just to show that quickly, 7 divided by 100, of course. You can do that on your calculator if you really need to. But one thing that we can notice about what just happened when changing a percentage to a decimal is this concept here. We basically drop the percent symbol and we move the decimal point 2 places to the left. And you could think to yourself, well, why to the left? Well, because if the percent symbol means divide by 100, we're making the number smaller. So to make the number smaller, we'd move to the left. And it's always 2 places no matter what, because it means per 100. 100 is 2 factors of 10, and so it's always going to be 2 places. So here we could use our little shortcut method. It says write each percent as a decimal. So I'll start, I'll recopy 54%. We can now drop the percent symbol. Where's the decimal? Well, it's right after the 4. 2 places to the left, 1, 2. There's where the decimal goes now. And so I'm going to write 0.54. Okay, similarly here. Now some students will ask, when they read this, they'll say, it says write each percent as a decimal. Some students will say to themselves, well, this is already a decimal. Well, it is a decimal, but it's a decimal percentage. And so you want to get rid of the percent by, once again, I'm going to recopy. And we'll recopy the numerical portion, 2 places to the left. These little loops are helpful, 1, 2, because if you use those little loops, then you can see that there's a little space between the decimal and that 3, and we need a placeholder. And of course, we're going to use 0. And so 0.031. Okay, 0.01%. So again, I'll recopy. And 2 places to the left. 1, 2. There it is. Another need for the placeholder. And then I'm going to put the 0 out in front of it. So 0.0001. And so to go in the opposite direction, to change a decimal to a percentage, we're just going to reverse the process by moving the decimal point. Again, it's always 2 places, but now to the right. And then we're going to add the percent symbol. And just always remember it's 2 places, and to remember left or right, here's a little memory trick. Just write down D and P in alphabetical order, decimal percent. If you're going from a decimal to a percent, it's to the right. And if you're going from a percent to a decimal, it's to the left. Now, that's just a little memory trick. The way I always think to reason it out is the fact that percentage means per 100. So if you're going from a percent to a decimal, you're dividing by 100, so you're making the number smaller, so that means to the left. And the opposite situation, of course, decimal to percent is to the right. So these are decimal numbers, changed to percentages. I'll rewrite 5. Where's the decimal? Follows the 5. 2 places to the right. 1, 2. Add the percent symbol. Looks like we need some placeholders. So 5 means 500%. 0.25. Some of these you can almost do by inspection. These are kind of easy ones, and some percentages that are common, but to show it formally, like 0.25, 25%, but to show it formally, 0.25, 2 places to the right, add the percent symbol, make it look cleaner, and we have 25%. Okay, similarly here, 0.01, 2 places to the right, add the percent symbol. So it looks like 1%. All right, moving on. On the next page, we're going to look at the next concept, which is to write a percent as a fraction. We basically did that in our first example. We just wrote it over 100, the numerical portion of the percentage. So 8% can be written as 8 over 100. And reducing it to lowest terms, use your calculator if you like. I'm going to recognize that 4 is the greatest common factor, and we get 2 over 25 in reduced form. Here's a special example. We're going to start by writing it as a fraction, dropping the percent symbol, the numerical portion of 1.4 over 100. But now this is similar to a situation we saw in homework 1, where we have a decimal mixed with a fraction. And remember, we don't want that. So we want to move the decimal point so that this 1.4 becomes a whole number. Before we do, let's make each number have the same place value by adding a trailing 0 to the 100. So I'm going to call it 100.0. And then I'm going to multiply by the appropriate power of 10, which in this case is 10. So that becomes 14 over 1,000. And now I could reduce. Let's divide by 2. And that gives us 7 over 500. Okay, so remember there's a little trick as well. If you don't like this multiplying by 10 idea, there's a little trick of just moving the decimal point one place here, and then you'd have to move it one place here, so that adds a 0. So if you can think proficiently like that, that would be fine also. But no matter how you do it, ultimately we get 7 over 500. Okay, now to write a fraction as a percent, you can't do it directly. You first have to go from a fraction to a decimal, and that's by just division, and then change the decimal to a percent. And remember, that's by moving the decimal point 2 places to the right and adding the percent symbol. So you don't want to go through long division, just do it on your calculator. 3/4 is equal to, okay, it's just simply on your calculator, 3 divided by 4, so kind of insulting to show you that, but just so we see it, 3 divided by 4 is 0.75. And then we want to change that to a percentage. So 2 places to the right, I'm going to recopy it, 2 places to the right, and add the percent symbol. Then I'll make it look a little cleaner, and that's 75%. Okay, so again, can't do it directly. Go from a fraction to a decimal, and then to the percentage. So one more practice problem here, 7 divided by 20. Definitely something you'd probably use your calculator for. So it's just basic division. So let's say 7 divided by 20 is 0.35. And now that's a decimal. Now we go from the decimal to a percent. So 2 places to the right, add the percent symbol, and we get 35%. Okay, so the next thing is a concept that requires a formula, but not really. I mean, you could memorize it, but it kind of makes sense. It's for the percentage of increase or decrease. It's the same formula no matter if it's an increase or a decrease. And the percent of increase or decrease is found by finding the amount of increase or decrease, or that's the change or the difference, divided by the original amount. And so in this example, we have a painting that goes up in value from $250 to $400. Just note that the $250 is the original amount. And so we're first going to find, now this is an increase problem. We want to, and they even told us the amount of increase and the percent increase. So the amount of increase is the change or the difference. It's always the high minus the low. So in this case, $400 minus $250. So it changed by $150. And so then the percent increase is equal to, you don't have to write the formulas, but just to be formal here, the amount of increase divided by the original. I'll just say the original. You could say the original amount if you like. So the amount of increase we just found, that was the $150. And the original amount was the $250. Now notice that I kept the unit symbol there. And I know as you guys go through the problem, you probably won't, and it's okay not to. But now we can cancel the units, and we get 150 over 250. Do the division, and that obviously is done on the calculator. Feel free to do long division if you like, but 150 divided by 250 is 0.6. But that's a decimal, and that needs to be changed to a percentage. So in these problems, the percent of increase that you find after you use the formula and you divide, that needs to be changed to a percentage. And so therefore, the percent of increase is, okay, it was 0.6, but two places to the right, add the percent symbol, need a placeholder, looks like 60%. Okay, and we have another example. And this is for a percent decrease. Now sometimes they just tell you in that part, in that last example, we were told to find the amount of increase and then the percent of increase. In this example, it just jumps immediately to saying find the percent of decrease. So you have to know, if you want the formula, percent decrease is the amount of decrease divided by the original amount, or I'll just say the original. Okay, so if they don't ask it in two parts, you have to know to find the amount of increase or decrease first. And the amount, in this case, of decrease, you always take the high minus the low, so you don't get any negative numbers. Just note what the original was. That's very important. In this case, the 500 was the original. So the amount of decrease is 500 minus 425, or 75. And notice here that I'm not even bothering to use the units, but I guess I should, right? But you don't have to. So let me give you an example where most likely most students are going to go this way without the units of dollars. Because you're dividing by dollars, so they're going to cancel like they did anyway. Okay, so the percent decrease then is the amount of decrease, what we just found, divided by the original amount. And the original was the 500. So use your calculator for that. Get 0.15. Change that to a percentage. So 2 places to the right, 1, 2. Add the percent symbol. Clean it up. And we have 15%. Okay, so the next thing is to solve basic percent problems. And there's 2 ways to do it. You can use the proportion method or the equations method. And so we're going to show both methods, and I'm sure you've seen this formula before. We say part over base is equal to the rate over 100, where you have to think of the base as being the whole, the part as being the portion of that, and the rate is always your percentage. So the rate is easy to find. It's easy to identify in a problem because it's the percentage. It's either going to be given or you'll have to find it. And one thing you can guarantee is that in this equation there are 3 things that are unknown, but 2 of them will always be known, and you'll be asked to find the 3rd. And one statement I would like you to consider that will help you solve these problems is the fact that it is the percent of the base that is the part. So we're taking the percentage of the whole to give us that portion. And with that statement, I want to remind you of I think, a formula, the same formula but in a different form using different words. You probably will remember is over of equals percent over 100. That is, what follows the word is represents the part. So notice that's in the numerator. What follows the word of represents the base. That's in the denominator. And we've got the rate. The rate is your percentage over 100. So it's really not proper to use this form, although many instructors show it, just as I'm showing it. But I'm going to use, when I solve these problems, if you want to think of is over of, that's fine with me. But in some word problems, it doesn't really, the is over of, you have to be a little bit careful. You really need to know that the base is the whole or the quantity under consideration. The part is the portion of that, and the rate is your percentage. So I'm going to stop the video right there. We're at the 24-minute mark almost, and then we'll come back and we'll actually use this to solve some problems, and we'll look at the equation method also. So we'll do 2 parts for this lesson.